Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And I'm not telling you this looking for sympathy at all, just an explanation is that I have had Crohn's disease for about 30 years and I get an infusion of certain medications every so often to sort of keep it in check. And I've always felt guilty telling people I have this because for the most part, I'm asymptomatic. There are an awful lot of people out there that have Crohn's that it's a daily struggle. And to be honest with you, it just hasn't been overall nearly as bad as that for me. But anyway, I went in this morning at 9:30 and a new drug was started and I immediately had an allergic reaction to it. My oxygen level dropped and I started to feel like my breathing was shallow and all that. And so then they had to stop it, give me something to relieve those side effects, and then tried it again with a flow rate of 50%. And that worked wonders. But it meant I had to stay there twice as long. And so hence the delay in getting this bonus weather video to you today. All right, so the idea today comes from one of my subscribers again, and really concerns the fact that hurricanes are way more than just wind, okay? And so let's go on ahead and take a look at some of the different aspects of a hurricane and what sort of dangers it presents. All right, so important things to know. The Saffir-Simpson scale is used to categorize hurricanes, and it only applies to the maximum sustained wind speed within the storm, anywhere within the storm, and it provides an estimate of the property damage based on that. Now, if you actually read the definition, it will also make an estimate on storm surge, but storm surge, as you'll see in just a few minutes, is dependent on a lot of different things, not just the wind speed. So it's really sort of unfair to estimate storm surge based on the maximum sustained winds in the storm. There are a lot of other things to look at, and again, we'll talk about that in a second. Hurricane warnings can now be issued for inland counties if hurricane conditions are expected inland. So let's say you live in Duplin County or Bladen County. You might think, oh, I'll never get a hurricane warning because I'm not on the coast. Well, if you're going to have hurricane force sustained winds, or at least the possibility of thereof, then you may very well get a hurricane watch or a hurricane warning, even though you are not actually on the coast. All right, and a new experimental forecast cone is going to start coming out in mid-August, and it'll be slightly bigger to drive home the point that a hurricane is not a point, but a large circulation that can have far-reaching effects. And, this is something that is probably not talked about enough, is that, even if you have a storm that is, on the edge of the cone, let's say it's a Category 3, the hurricane force winds are going to extend outside the cone, and 1/3 of the time, the storms don't even stay within the cone. And so let's say it's outside the cone and you've got a Category 3 and the maximum sustained winds, hurricane force winds go out 30 or 40 miles in all directions. There's significant impact outside of that cone and pretty far outside of that cone. Okay, let us go ahead and take a look at the Saffir-Simpson scale, just to remind you. And Category 1 is max sustained winds 74 to 95, 2 is 96 to 110, 3 is 111 to 129, 4, 130 to 156, and 5, 157 plus. And there have only been 4 of those that have ever made landfall in the United States. And remember, actual observations may very well not be as high as the max sustained winds reported in the NHC advisories. And this is because the max sustained winds are located in small pockets within the eye wall, okay? So the probability of one of those pockets going over an observing station is very, very small. And so a lot of people think, oh, they're just hyping it and giving higher numbers than actually are there. It's not the case at all. It's just that if you look at it from a probabilistic standpoint, again, the chance of one of those pockets going right over top of an observation station is pretty darn small. Okay, the NHC forecast cone for 2024, and these are the forecast hours on the left, and then the radius of the cone at that particular forecast hour. And remember, the average error, and this is based on data from 2019 to 2023, the last 5 years, 30 miles would mean 30 either side, okay, of the middle of the cone, okay? So this is why I really don't like people showing the line in the middle of the cone, because anybody within that cone is fair game for the center of the storm to go. And if you think about it, if the average air, let's say in 48 hours is 81 miles, if you concentrate on the line, that's where it won't be, okay? If the average air was 0, that'd be great, but it's not, okay? And it really gets large, as you can see, as you go out in time. And so the line just ought to be eliminated, to be honest with you, and it should just be the cone, and everybody within that cone needs to realize that the center could go in that region. Okay, and notice by 120 hours, the average air is 253 miles. And it says 2/3 probability circle, which means that the chance of the center of the storm being in the cone is only about 66, 67%. So 1/3 of the time, the center goes outside of the cone, okay? So, the cone is not, the be-all and end-all, if you will. It's a good starting point, but you need to realize that there's some wiggle room there. Okay, how the cone is produced. If you take all those forecast errors I just showed you and create a circle, okay, that has those dimensions, and then you put all of those circles together like that, you can see they get bigger out in time, and then you basically construct the cone based on all of those circles. And so that's what the forecast cone would look like in this particular example. Now, we also have something called storm surge. And again, the maximum winds don't always tell the story on how bad the storm surge is going to be. So the National Hurricane Center in recent years has started issuing storm surge watches and warnings, okay, which are completely separate from the hurricane watches and the warnings, okay? Because you may end up getting a storm surge with a tropical storm, but it could still be as bad as some storm surges in hurricanes. So you need to be aware of that. Now, there are a plethora of contributing factors to what the storm surge does, how bad it is. There is a very small contributions from the storm's low pressure, and this would be more of an issue in a Cat 4 or a Cat 5, the air pressure being so low that it allows the water level to come up a little bit, but that's a very, very small contribution. The stronger the winds, the bigger the surge. You're driving water toward the coast and the ocean bottom is coming up and it's getting shallower. The water is getting shallower and shallower, so it can't go down, got to go up. And that's the main problem with storm surge. The storm's forward speed also has an impact here. So if the storm is moving rapidly toward the coast, it's piling up water at a quicker rate. And so again, that's going to make the water level even higher. The width and slope of the ocean bottom, is it a very, very gradual slope up to the beach, or is it sharper, okay? And if it's sharper, then that can be a real problem in the sense that it's really going to force that water to go up in a hurry. It's almost like you're going to be driving along a flat road, and then all of a sudden, like some of the hotels down here in Myrtle Beach, you drive in, and all of a sudden you're going up like this to get to the main entrance. Okay, so that can have a far-reaching effect. The angle of approach to the coast. Okay, if you think about this, if a storm is going perpendicular to the coastline, it's going to have a greater effect than if it's sort of hitting it at a very, very shallow angle. So that's another contributing factor. The size of the storm also matters, because if you have a large circulation, then you are taking water over a large area and driving it toward the coast, as opposed to a more compact storm where the overall area of water that is being affected is not as large. The shape of the coastline has an effect, okay? Let's say your coastline is sort of curved like this, okay? So that's going to force the water on this side to come in like that, and on this side to come in like that, and you combine those two, and that's going to increase the storm surge as well. And then finally, local features, and the Outer Banks there is no better example than the Outer Banks in North Carolina, such as barrier islands, inlets, sounds, bays, and rivers. All those things are going to play a role. Now, last but not least, inland flooding, and the emphasis here is definitely not on least, okay? Around 60% of tropical cyclone-related deaths are caused by inland flooding, and that surprises a lot of people, but the statistics are there to back this up. And 1 foot of water can float a car, especially if it's fast-moving water, and 18 inches can float a large vehicle or a truck. Now, if the water is stationary and just sitting there, you can probably get away with a little bit more than this, but it's very difficult sometimes to tell how deep the water is, and so somebody will say, it can't be deeper than 6 inches, I'll just drive across that, and the next thing you know, their car is being carried away somewhere. So again, inland flooding is can be a very, very big deal. In fact, it's responsible for more than half of tropical cyclone-related deaths. Okay, there are the credits. That is bonus weather video number 1 for this week. Number 2 will be coming up tomorrow afternoon or evening. In the meantime, have a great Tuesday evening, everybody. Hope that was helpful, and we'll talk to you again tomorrow. See you later.